Hello guys and welcome back. So we have the geometry to upres, and I'm gonna work on it. Sometimes when you work with the packed primitives, you isolate certain pieces and stuff like that. The viewport tends to glitch. So what we can do is we can switch back and forth between a different panel and back, and that will refresh the OpenGL cache. Okay, so let's work on this. I'm gonna unpack it first, and we want to Voronoi the pieces. So let's dive inside. So if I zoom in, you can see there's a lot of issues in this mesh. It's not going to show up in the final, and probably I fixed it, but I want to show a quick way on how we can fix this. So after we unpack, and let me turn off the color. After we unpack the geometry, I'm going to use a fuse node. Fuse node, and I'm gonna increase the radius until it snaps, until I fix all the cracks, something like that. The only thing is I don't want to, if I fuse it, this is a big gap, so if I fuse it and leave it like this, it's gonna mess up the information about the interior surface and stuff like that. So what I need to do is fuse snap point turned off. And this way, now we fixed the few of the gaps. I should have taken care of that when I fractured it. But if we do an exploded view, we should see everything still the same. Okay, so now let's do a for each name primitive, because each piece has a name attribute. And let's go. So we have the geometry. I'm going to fuse it, and I'm going to divide it, make sure that it's all triangles, and this ensures that if I fracture it now, it's not going to cause any issues, because when we have n-gons and we fracture them, it tends to create weird surfaces. With this way, it's going to be clean. So let's gather just 5 or 4 points. Let's go with 4 points. And this means that we're going to increase the resolution 4 times. And just for this test, it's fine. For the final one, you probably want to increase this more. Okay, so let's see. This is our geo. This is the original geo. You can see there is no difference visible, but this one has more pieces. So if I view the piece by color, you can see we have different ones. And if I disable these two, you will notice that you see we have issues already. So we have to make sure that we fuse and divide the geometry. And if we do finish the for each loop and go over all the pieces, we're gonna fracture everything 4 times. Now I'm gonna pause here. You can see that the process is a bit slow. What we can do to speed it up is using a compiled block, and this will multi-thread the process, and depending on the type of CPU you have, you may see quite a boost. See, it's faster. Okay, so we're uprising the geometry, and then what we want to do is to continue the RBD simulation that we started. But now we screwed up few things. We messed up few things, and we need to go back and fix them. But let's take a look at this one first. Let's turn off the color, and that's our original geometry. It looks exactly the same, but my idea is that we want to keep this. I don't want to change my sim because I like it. And now I can't do that anymore because this geometry is completely different. So how can we keep this? How can we keep our movement and apply it to this new geometry? Well, we can do that using a name attribute. But unfortunately, when we did the fracture, that is gone. The name attribute is gone. So before we do this appres, we need to store the original name attribute. So if I middle click here, we have this name attribute, 2500 pieces, and we want to keep that. So I'm going to create a wrangle attribute, and I'm going to change it to primitive and call this name underscore core is equal asset name. So now I'm making a copy of the name attribute, and it's called name core or name base. Let's name it base. And then when we do this, we're fine. We still have a copy. It's going to persist in the geometry, and everything is going to be fine. Okay, so let's try. I'm going to copy this. These are our points. And if we play, it's not working. And the reason for that is because these points, they are looking for a name attribute. We don't have a name attribute. Well, we have, but it has no relation. So we need to make the same thing with this. We need to make a copy of the name attribute here as well and call it name underscore base. Okay, so let's change it to points, because now it's working on points. This is wanted to cache again. Okay, so we have a name underscore base, and now it's still not working. The reason is because the transform pieces need to use that attribute. And now if we do this, that's our appraise, and it's working. Great. So the last part we want is how are we going to activate this? Because if we use a RBD solver now on all of this, it's not gonna work. The pieces are just going to fall, but we don't want that. We want them to continue this behavior, and then we want to trigger them. We want to control trigger them. Okay, so the next video we're gonna see how we can tell the piece after a certain condition, hey, you're ready now, go become active and activate all your pieces so everything starts to crumble. But we don't want that to happen at this frame, for sure. We don't want it to happen at this frame, because there's still stuff that are moving, and we want to see that movement. So we're gonna set up a system to do the activation in a smart way, and then we'll plug this into an RBD sim and see how it looks. Thank you guys for watching, and see you in the next video. Bye bye.